And our objective for today is I can solve and graph quadratic equations. And today we're going to use it just to kind of clarify some questions. So we're going to go over some of the questions from the home plate. And then from there, we're going to move on to just so you can see a couple of things in regards to graphing. Because for tomorrow's part A, I want to make sure that we got all the questions answered by today. Yes? Yes, there's a party tomorrow, and there's a binder check tomorrow. Part A, my bad. Oh, you wanted to count as a binder as a part A? No, it's going to be a small one, but some of you are going to need time to do your work because I don't want, like, for those of you that write like cavemen or whatever, do a nice job. Anyways, so we already know what quadratic equations are, right? I already gave you these steps, yes. And then we did some practice, such as this one, yes. Then we did this one, yes. And then for home play, we've been doing, no, not that one. We've been doing stuff like this, right? So copy this one. We're going to do this one together just to make sure we got all the steps down and that everybody understands step by step what you need to do for tomorrow's part A. Did everybody understand that? Okay? Because I don't want any to, oh, Mr. Q, you didn't tell us. I mean, not that you guys talk like that. All right, here we go. Example number 3. Y equals 2x squared plus 5x plus 3. So, first step. What is step 1, everyone? Solve for y. Is it already solved for y? Yes. And what also did it say in parentheses? Standard form. It's already in standard form. Okay. Step 2. Substitute 0 for y. So it's 0 equals 2x squared plus 5x plus 3. And everybody's doing this one with me, right? Okay. From there, next step, Chris B. Yeah, Chris B. Factor it out. Okay. So what do we check first? Is there? No. So therefore, power meters. What goes on top? That is correct. Now check this out. For those of you that forgot, make sure you label it right now so that you won't forget tomorrow that if it has a leading coefficient greater than 1, you need to multiply the leading coefficient times the last term. That's how we got that 6. So factors of 6 that add up to 5. Let's see, 1 times 6, 2 times 3. 2 and 3, that is correct. Let's rewrite this. So then we rewrite this again. 2x squared plus 2x plus 3x plus 3, and all that equal to 0. Bless you. Next step, Gianna.
You're going to put them in parentheses and find the GCF?
Put them in parentheses, find the GCF.
No. 2 different sets of parentheses.
2 different sets of parentheses. All right. So we group them, and what is our GCF for the first 2? 2x. We're left with x plus 1. GCF for the last 2, 3, and we're left with x plus 1. All that equal to 0. And let's see, what are our factors then? X plus 1, 2x plus 3, and all that equal to 0. Next step, Seabass. Close. Look where we're at. ZPP, zero product property, which means we need to set each one equal to 0. X plus 1 equal to 0. 2x plus 3 equal to 0. All right, let's solve. That's the next step. Therefore, -1 minus 1, x equals -1, minus 3 minus 3, 2x equals -3, divide by 2, divide by 2, x equals -1.5. Bless you. These are my x-intercepts, my roots, my zeros, my solutions. Yeah. If you know how to graph it, that's fine. You ever hear the question? Could we have left it as -3 over 2? Yes, if you know how to graph that, that's fine. All right, let's graph this. So get your coordinate plane over here going. What's our y-intercept, everyone? 3. Tell your neighbor y. Okay, so what is our y-intercept? What is 3 our y-intercept, boss? It's a constant. Okay, that's one thing. But why was the, first of all, why did we make y 0? What was that strategy that we used? No, that's when we make each one of these equal to 0. I'm saying, why did we substitute y for 0? What method did I show you with linear equations that were similar to that? Pedro. Santi, sorry. Santi. What is it? Cover-up method. You guys remember? When we cover up, it's basically substituting y for 0, yes? So therefore, if I cover up the y, I end up getting my x-intercept. But if I substitute x for 0, watch, or 0 for x, what is 2 times 0 squared? What is 5 times 0? What is 0 plus 0 plus 3? That's how we find our y-intercept. That's why we know that that's our y-intercept. Does everybody see that? All right. Our x-intercept is -1, which is right here. -2 is over here. Therefore, -1 and 1/2 is about right there. All right, let's graph this. And just a refresher, if a quadratic equation has a positive coefficient, it's a happy face, yes? If it has a negative coefficient on the first term, it's a frown, yes? Therefore, we go from left to right. And there it is. For these, you can't, because we're practicing our artistic skills with this. And I know some of you are really good at sketching. Bless you. What? And let's go to the next one. Copy this one on paper. Yes. Oh, it said to check. We didn't check. Thank you. Okay. Here we go. So we're going to take our first equation, which is this one, the original one. I'm going to take y equals 2x squared plus 5x plus 3. And right now we are checking. And we're going to substitute one value. Let's see. The first value we're going to substitute, you want to do -1.5 or -1? -1. All right. So then what is this point right here? It's -1 comma 0. So therefore my x value is -1 and my y value is 0. So let's substitute that in there. My y value is 0. My x is -1. Bring everything else down. Squared plus 5 times -1 plus 3. Let's see. Negative 1 squared is 1, so what is 2 times 1? Okay, here it goes again. Negative 1 squared is 1, times 2 is 2. What is 5 times negative 1? Negative 5 plus 3. All that equal to 0. You can combine like terms. Yes, Mr. Q. All right, good. 2 plus 3, 5 minus 5. And that's how you check. You saw it? Yes. That's a good question. Let's try negative 1.5. Everybody say thank you, Santi. Y equals 2x squared plus 5x plus 3. But now we're going to check the other, which is negative 1.5 comma 0. So this is 0 equals 2 times negative 1.5 squared plus 5 times negative 1.5 plus 3. Let's see. What is negative 1.5 times negative 1.5? Times negative 1.5, because that's squared, right? What is it? Okay, here it goes. 1.5 times 1.5, 25, we got 2, 5, that's 7, 5, 1, 5, 12, 2, 2 decimal places, that's 2 times 2.25. This is 5 times negative 1.5, that's negative 7.5, is that correct? Yeah? Plus 3. All right? So what is 2 times 2.5? That's 4.5 minus 7.5 plus 3. All that equal to 0. So it is combined like terms. 4.5 plus 3. 7.5 minus 7.5. It should work, right? Because we said that those are solutions to the equation. All right. Ready? All right, let's move on. Yeah, comment. Thank you, but I make mistakes, right? Like everybody. No, but I do those on purpose. Copy this one, please, on your paper. Be nice. Here we go. Step 1, solve for y. There's no y, and it looks like they already substituted for 0 for y, yes? Step 3 is factor. They already factored for us. So this is, they left it easy for us. What is our next step, everyone? ZPP, x plus 4 equal to 0, x minus 3 equal to 0, and we solve. Minus 4 minus 4, x equals negative 4 plus 3, x equals 3. These are my x-intercepts, my roots, my zeros, or my solutions. Let's graph. Can somebody give me the y-intercept? Hands for that. Angel. Negative 12. Oh. Yeah, it goes down here. Tell your neighbor how we got that, please. Talk it over with your neighbor. How we got negative 12. Okay? So, be nice. Multiply the both constants, and that's how we get our y-intercept. So my roots are negative 4, positive 3, And let's see, what is x times x? Positive x squared, so it's a copy paste. As if you got that. Yeah? All right. So, yeah, question. Is your what? Squiggly line. Okay, let's call it what it's called. What if my parabola? What if my parabola is not as nice as somebody else's? So you guys want me to dock points? No, be nice. Just try your best. Try your best to sketch it. Now, if you're going to do something like this, like you're going to go. Yeah, of course I'm going to dock points. It has to be correct. But yeah, I mean, if you have like your post is all over the place. Oh. Yeah, no. No. Here it is. X-intercepts, roots, zeros, and solutions. Move on. On this one, we're going to skip the check for right now. Here we go. Let's go to the next one. I'm going to send you this one to your iPad and do this one on your iPad. It shouldn't take you more than 30 seconds. Ready? Lock your toolbar. Ready? Go. Example 1A, copy this. X times x plus 4 equal 0. We're going to do this one together. Here we go. So, step 1, solve for y. And they already substituted that for 0. Okay, so they're ahead of us. Step 3, factor. Did they factor it already? Yes. So next step is ZPP, x equals 0, x plus 4 equals 0. Let's solve. This one's already solved, so we subtract 4. Subtract 4. X equals negative 4. Therefore, these are my x-intercepts, my roots, my zeros, my solutions. Okay, let me graph this. Okay, before you give me an answer, here goes a question. Don't say it out loud. Think it through first. What is my y-intercept? Think it through first. Look at what we have in front of us. Talk it over with your neighbor. What is our y-intercept? Okay, let's see. What'd you get for your y-intercept? Go ahead, Dylan. What is it? 0? How did you get that? Where did you get the 0? Oh, what Dylan is saying is that this one does not have a constant or a second term in there. So if it would look like this. So therefore, 0 times 4 is 0. That's my y-intercept. Okay? So, oh, I already placed my y-intercept. There it is. Now let's plot our X-intercept. What's our X-intercept? 0. There it is. And what is my other root? -4. Okay. Now, let's see. What is x times x? X squared. That's a positive, so it's a happy face, right? Here we go. From left to right. Copy that. For right now, no. But very good questions. We're going to get there. Yeah, we're going to be more precise with our graphs. This, what we're doing, by the way, for those of you that didn't realize, if you notice on your textbook, they have a lesson, and the lesson is just solved by factoring, right? But Q style is solve by factoring and graph it using our x and y intercepts, yes? So that you can see it in context what it looks like. Because we are going to get to the other parts, but by now you should be able to see what it looks like before we graph it. All right, I'm going to send you another one so you can do it on your iPad. Here we go. All right, so exit out of the program already. I'm going to go to the home play. I'm going to show you, let's see, it was 584. Yeah, 583, 584. But where I'm going is I'm going to show you this one word problem that I wanted to cover with you really quick as you're logging out. Okay, look up, please. It says, the height of a model rocket launch in the air from the rooftop is given by the quadratic equation h equals -16t squared plus 64t plus 80. Do you guys see how this one, instead of writing y, they have h, and then instead of x, we have t, right? But the process is the same. Now, the question was on the home plate, you got two answers. You got t equals -1 and t equals 5. So, what would be the answer to this question? At what time does a rocket land on the ground? Talk it over with your neighbor really quick and tell him why. Okay, America, what did your neighbor say? 5. Why? Time cannot be counted in negatives nor distances, right? So the correct answer is 5 seconds. Your home play for tonight is found on page 615. Good one, everyone. Enjoy your home play. Be ready with your binders by tomorrow. See you guys tamales. Yeah.
Is that all I have to turn in?
For right now, yes.
Okay.
Thank you.